In this video, we are going to see the problems based on algebraic formulas. First problem, find L of t square plus 1 the whole square. This look like a plus b whole square formula. Here a value is t square, b value is 1. Using this a plus b whole square formula, we can write this term as t square plus 1 the whole square equal to t square the whole square plus 2 into t square into 1 plus b square. B value is 1 square. So we'll get the value as t power 4, and then here it is 2t square plus 1. Now we can take Laplace transform for this function. L of t square plus 1 the whole square equal to L of t power 4 plus 2 into L of t square plus L of 1. So we know that L of t power n, where n is an integer, we can write the term as n factorial divided by s power n plus 1 is the formula. Applying that, we will get the answer as 4 factorial divided by s power 4 plus 1 is 5 plus 2 into n value is 2 here, 2 factorial divided by s power 2 plus 1 is 3. L of 1 it is look like k by s, that is 1 by s here. If you want, you can simplify this. 4 factorial is 1 into 2 into 3 into 4. The value is 6 into 4, 24. So 24 divided by s power 5 plus 2 into 2, 4 divided by s cube plus 1 by s is the required answer. The next problem is Laplace transform of root t plus 1 by root t the whole cube. Using a plus b whole cube formula, we can write this root t plus 1 by root t the whole cube as, that is root t the whole cube 3a square root t the whole square into b plus 3ab square root t the whole square plus b cube is 1 by root t the whole cube. Since we can write this root t as t power of, so I can write the first term as t power 3 by 2 plus here 1 by root t, and root t is getting cancelled. So here we can write t power root t as of, t power of I can write. Similarly here 1 power will get cancelled. So therefore the denominator will have 1 by t power of plus here the same process 1 by t power 3 by 2. So here I can write 3 by 2 plus 3 t power of plus 3 t power minus of. We can take it to the numerator and write, or we have to multiply the numerator and denominator by t power minus of. Okay, and here multiply numerator and denominator by 3 power minus 2. So we'll get this value. Therefore L of root t plus 1 by root t whole cube equal to, we can write L of the first term is t power 3 by 2 plus 3 is constant, take it out. Second term is L of t power of. Third term is 3 into L of t power minus of. The last term is L of t power minus 3 by 2. Okay, so now it does look like fraction form. Laplace transform of t power n equal to gamma of n plus 1. So therefore here n value is 3 by 2. We can write 3 by 2 plus 1 divided by s power 3 by 2 plus 1 plus 3 into gamma of n plus 1 divided by s power n plus 1. Here n value is off. Here 3 into gamma of n plus 1. N plus 1 divided by n plus 1. Here the n value is minus of. Gamma of minus 3 by 2 plus 1 divided by s power minus 3 by 2 plus 1. We can first simplify the numerator. Gamma of 3 by 2 plus 1. So it is look like gamma of n plus 1. So gamma of n plus 1 can be written as here n into gamma of n. So therefore I can write this as 3 by 2 gamma of 3 by 2. Next I can write this 3 by 2 as n plus 1 format. That is 1 by 2 plus 1. Gamma of plus 1 can be written as of into gamma of. Stop the process because we know the value of gamma here. Here I have given the gamma values. By seeing that gamma values, we can write this as 3 by 4, 2 into 2, 4 in the denominator. Gamma of half can be written as root pi. Numerator is 1 by 2 plus 1. It is also look like n plus 1 form. We can write this as n into gamma of n. So here 1 by 2 into gamma of half is root pi. We can write this term as root pi by 2. Next one minus of plus 1. So that is gamma of half. So gamma of half we know that is root pi. Gamma of minus 3 by 2 plus 1. If you simplify this, we will get, if you just add the two terms, we will get minus of. So we know the value of minus of, that is minus 2 root pi. So finally we will substitute that in the previous step. So therefore we will get gamma of 3 by 2 plus 1 can be written as 3 by 4 into root pi. The denominator consists of s power 3 by 2 plus 1, that is 5 by 2 plus 3 into. So gamma of half plus 1 can be written as root pi by 2. The denominator is having s power half plus 1, that is 3 by 2. So next plus 3 into gamma of minus of plus 1 can be written as root pi. Can write root pi. The denominator is s power of plus gamma of minus 3 by 2 plus 1 can be written as minus 2 root pi divided by s power minus 3 by 2 plus 1 is minus of. Therefore, L of root t plus 1 by root t the whole cube can be written as, you can write this as 3 into root pi 4 into s power 5 by 2 plus 3 root pi divided by 2 into s power 3 by 2. And then I will take this s power of as root of s. So therefore I can write 3 root pi by root s. The next term minus root pi, I will take that minus of to the numerator or multiply the numerator as well as the denominator by s power plus of. So we will get s power of in your numerator. The denominator is s power 0, that is 1, equal to, we can rewrite that term as root pi 3 root pi by 4 s power 5 by 2. 3 root pi by 2 into s power 3 by 2, and then this can be written as plus 3 into pi by s. Here this can be written as root of pi s is the required answer. Similarly, you can find the term L of root t minus 1 by root t the whole cube using this a minus b whole cube formula. The next problem is L of sine t minus cos t the whole cube. Using a minus b whole cube formula, we can write the sine t minus cos t the whole cube as sine cube t minus 3 sine squared t cos t plus 3 sine t into cos squared t minus cos cube t. Since here a is sine t, b is cos t. Apply in this a minus b whole cube formula, we will get this step. Now we know that sine square theta plus cos square theta equal to 1. Using this, I can write the sine square t as 1 minus cos square t, as well as here cos square t as 1 minus sine square t. Substituting that here, and I have multiplied the terms and I have written the terms as sine cube t minus 3 cos t plus cos cube t plus 3 sine t minus 3 sine cube t minus cos cube t. So then we can add this cos cube, and I can write the term as 2 cos cube t. And I have simplified the sine cube t, that is minus 2 sine cube t. Remaining terms minus 3 cos t plus 3 sine t. Now we know the formula of cos cube t, sine cube t. I have applied the formulas and I have simplified the term. Here 2 and this 2 will get cancelled, you will get 1 by 2. Here also you will get 1 by 2. If you multiply, you will get 3 by 2 into cos t plus cos 3t by 2 minus of plus minus 3 by 2 sin t minus of minus plus sin 3t by 2. So remaining term minus 3 cos t as it is plus 3 sin t as it is. If you add this cos 3t, here you can write the term cos 3t by 2 as it is and sin 3t by 2 as it is. Remaining cos t and sin t can be simplified as 3 by 2 cos t minus 3 cos t can be written as minus 3 by 2 cos t. Similarly, we can simplify the sin t minus 3 sin t by 2 plus 3 sin t can be written as 3 by 2 sin t. For this, if you take Laplace transformation, you will get the required answer. The next problem is based on sine of a plus b formulas. We can write this sine of omega t plus alpha as sine of omega t plus alpha equal to a value is omega t, b value is alpha. Here we can apply in the formula and write sine omega t cos alpha plus cos omega t sine alpha. Here alpha is a constant. So if you apply the Laplace transformation, L of sine omega t plus alpha equal to, here cos alpha is constant, take it out. Apply the Laplace transformation only for the function t. L of sine omega t. Similarly, here sine alpha is constant, take it out and apply the Laplace transformation for cos omega t. Now we know that cos alpha into L of sine at formula is a value is omega, so omega divided by s square plus omega square plus sine alpha into cos omega t formula is s divided by s square plus omega square. Here denominator is same, so we can add the numerator. Therefore, omega into cos alpha plus s into sine alpha whole thing divided by s square plus omega square is the required answer. If we ask the problems like this, use the above formula and you can simplify it and we can take the constant term out, apply the Laplace transformation only for the functions. The next problem is L of modulus of t minus 1 plus modulus of t plus 1. To solve this, we have to take the modulus condition, that is modulus of x equal to x if x is greater than or equal to 0, minus x if x is less than 0. So using this condition, we can write this modulus of t minus 1 as t minus 1 if t minus 1 is greater than or equal to 0, minus of t minus 1 if t minus 1 is less than 0. So if you simplify this modulus of t minus 1 equal to, here t minus 1 if t is greater than or equal to, I can take that 1 to that side and write the term as greater than or equal to 1. Here if you multiply by the minus, you will get minus t plus 1 if t is less than 1. The meaning of this t is less than 1 is 0 less than t less than 1. So that is the meaning of this. And here t is greater than or equal to 1 means t lies between less than or equal to 1 up to infinity. You take this modulus of t plus 1, it won't change the value in the interval, so you will get always t plus 1 only. So if you apply it here, we can write this as in 0 less than t less than 1, where f of t value is equal to. In this interval 0 less than t less than 1, we'll have here modulus of t minus 1 as 1 minus t. I have substituted the value. Already I told you this value won't change. So therefore modulus of t plus 1 is t plus 1 only. If you simplify this, 1 plus 1 is 2. Another condition in t is greater than or equal to 1. If it is greater than or equal to 1, so what is the condition? F of t equal to. Here greater than or equal to 1 is t minus 1. The modulus of t minus 1 is t minus 1 only. Here it is t plus 1. Here if you simplify it, you will get 2t. So therefore f of t can be written as 2t when t is greater than or equal to 1. So here it is 2 when t takes the value 0 to 1. Now we can apply the Laplace transform for this function. So L of f of t equal to, we have to apply the basic definition here, 0 to infinity e power minus st f of t into dt. So we can divide that into two intervals. So this is one interval, this is another interval. Here we can write this as 0 to 1 e power minus st f of t is 2 into dt, and then plus integral 1 to infinity e power minus st. In that interval 1 to infinity, we will have the value 2t into dt. Now we can apply the integral formula here. We can take the 2 out and integral 0 to 1 e power minus st into dt, and we can write integral 1 to infinity t into e power minus st into dt. Applying the integral formula, we will get e power minus at integral is e power minus at by minus s 0 to 1. So here we have to apply integral uv dx, since integral uv dx equal to uv1 minus u dash v2 plus u double dash v3 minus etc. Bernoulli formula. So here u value is t and v value is e power minus st. Applying the formula, you will get u into v1. v1 means integral of e power minus st is this. The next one formula minus differentiation of u, that is t differentiation is 1. Integral of again e power minus st by minus s the whole square you will get. So now apply that in limit 1 to infinity. So here we have to apply the limit only for the function t. Therefore take unnecessary terms out. So in the first term, I can take minus 2 by s out, and I am going to apply the limit for the t. So e power minus s into 1 minus e power minus s into 0. So next term, I can multiply the 2 and I will do the same process. From this, we can write minus 2 by s. And I am going to apply the upper limit as infinity. So infinity into e power minus infinity, lower limit as 1 into e power minus s into 1. In the next step, I can multiply by this 2. So minus 2 by minus s the whole square is s square. And I'm going to apply the limits e power minus infinity minus e power minus s into 1. If you simplify this minus 2 by s, e power minus s, e power 0 is 1. Minus 2 by s, since we know that e power minus infinity is 0, so it is 0. 0 into anything, 0. Here e power minus s. Same process, minus 2 by s square, e power minus infinity is 0, e power minus s. Since e power 0 is 1, e power minus infinity is 0. The next step, minus 2 into e power minus s by s, minus of minus plus 2 by s, here minus of minus plus 2 into e power minus s by s, here minus of minus plus 2 into e power minus s by s square. So I can take the LCM as here these two terms are same. I can cancel it. These two are getting cancelled. And I can take the LCM as s square. So here I can get 2s divided by 2s plus 2 into e power minus s divided by s square. From that I can take 1, 2 common, e power minus s plus s by s square is the required answer. The next problem is find Laplace transform of f of t, where f of t equal to, the problem is given like this. We must apply the basic definition of the Laplace transform to solve this problem. So L of f of t equal to 0 to infinity e power minus st f of t into dt is the definition, basic definition of Laplace transform. If you apply this, the 0 to infinity is divided into 4 intervals. So I can divide that 0 to infinity as 0 to 2 e power minus st. In that 0 to 2, your f of t is 1 into dt plus 2 to 4 e power minus st. In the 2 to 4, your f of t value is 2. Next, integral 4 to 6 e power minus st, your f of t value is 3 into dt. So next, integral 6 to infinity e power minus st, in that our function value is 0 into dt. So now we are going to integrate e power minus st, integration is e power minus st by minus s limit 0 to 2. So here 2 we will take it out. If you integrate this e power minus st, e power minus st by minus s, that limit to 4. Similarly 3 we can take it out. Integral of e power minus st is e power minus st by minus s, the limit is 4 to 6. So here it is 0. If you apply that limit for the variable t, e power minus 2s is your upper limit, e power 0 is your lower limit. Minus 2 by s we are taken out, and here e power minus 4s minus e power minus 2s, the lower limit. Here minus 3 by s we will take it out, and here e power minus 6s is your upper limit, minus e power minus 4s is your lower limit. If you simplify this, you get minus e power minus 2s, minus of minus plus e power 0 was 1. Here minus 2 e power minus 4s, minus of minus plus 2 e power minus 2s. Here minus 3 into e power minus 6s, minus of minus plus e power minus 4s, whole thing divided by s. Since s is common in this, we can take it out. Here 1 by s into, we will simplify the above term, that is minus 3 e power minus 6s I have written first. Here minus 2 e power 4s plus 3 into e power minus 4s. If you add that, you will get plus e power minus 4s. So next, if you simplify this, e power minus 2s, here plus 2, here minus 1. If you add, you will get plus e power minus 2s. And the constant term is 1 is the constant term. I can write the 1 here. So this is your required answer.